Welcome to another video session. In this session, we are still looking into the Unit 4, that is the combinational logic circuit. So what we have discussed so far is, first we had looked into the Boolean algebra, the properties and the theorems and the postulates involved in the Boolean algebra. And we have looked into the canonical and standard forms. We have also looked into the logic gates. In the last session, we have seen how we can use the Karnaugh map to simplify the Boolean expression and reduce the literals. So in this session, we will look into the simplification of product of sums and how we can convert from POS to SOP form and SOP form to POS form, which we have already considered in the canonical and standard forms. So here we will be using the map method to do this simplification. Okay, so the POS simplification. Let us take an example, that is product of sum simplification. So given here is a problem, a Boolean function. It is in the SOP form. We have to first express it in the SOP form, simplify that, and then write it in the POS form. So when we write the SOP form, so it will be SOP form in the full will be M0, M1, M2, M5, M8, M9 and M10. So it's a 4 variable function. F is a 4 variable function. So you will get 4 by 4, that is a 16 square Karnaugh map. And output is high for M0, M1, M2, M5, M8, M9 and M10. For all others, it is 0. Okay. So to obtain the POS form, what we are going to take is, we are going to take the output of zeros, not the ones. So which is unlike the previous problems, whatever we have done. So here we are going to group the zeros and apply the same technique of Karnaugh mapping. But here, instead of grouping the ones, we are grouping the 0 because we are not using the SOP form, we are using the POS form. All right. So we are, POS means the max terms. So max terms are nothing but related to the zeros, right? So therefore, we are going to group them. And you know that these 4 can be grouped, and these 4 can be grouped, and these 4 can be grouped. All right. So therefore, we have 3 terms by grouping them. And we are grouping all. This is 4. And this is 4. And this is also 4. So therefore, we have by grouping this 4, we get 2 literals eliminated. So by grouping these 2, we get B, C complement, D complement, and these 2 results with B, C, D complement, right? So when we club all these 4, we end up with B, D complement. All right. So this is for the complement. Now, by taking only the ones, this is F. So that means this is the simplified form by taking all the ones. So this I have not shown here. By taking all the ones, you can group them. So that means these 2 can be grouped, and rather these 4 can be grouped. And so these 4 are taken care. Next, these 2 can be grouped. Okay, so when you group these 2, you end up with so how many you end up with? Or rather 1, 2, 3, 4. When you group these 4, you will be ending up with 2 literals, and when you club these four, you will end up with two literals, and when you club these two, you end up with three literals. So we have three terms. So this is the sum of products for this function. So we are not writing in terms of the min terms. We are uh, directly drawing the corner map, identifying the points. That means the min terms in terms of the numbers, that is their decimal values, and marking the ones. Then we simplify for the ones. So this f expression is the output expression for which output is 1. All right. And this is the sum of product form. And we have simplified this. From this many terms, we have reduced it to this many terms. All right. So this is the sum of SOP form. Now we have to find the POS form. For the POS form is this example where we are going to group the zeros. So once we group the zeros for these four combinations, we ended up with B D complement. Similarly, for these four, for these four, we end up with AB because AB is here, and AB is 1 1. C and D are changing values. So these two will be, C and D will be eliminated. So these four combination or this four group, the group of these four zeros will result in AB, and the group of these four zeros will result in CD. So therefore we have these three terms by combining all these zeros. So therefore F complement is AB or CD or BD. BD complement. So AB, this is CD and BD complement. So this is your F complement. So what we are doing is we are trying to find the POS form, which is nothing but we are taking the complement. All right. Next, we write the POS form by taking the complement of this. So take the F complement. That means for whatever the functions, it is 0. You group them using the corner map, and then that is nothing but F complement. Then you complement that, then you get the F, which is nothing but the POS form. So this is the POS form, which is the result, which is the answer required for this question. So how do we obtain that? Is by taking F complement and you complement that result. So when you complement this, so wherever the AND operation is there, it'll become an OR operation, and wherever OR operation there, it'll become an AND operation. So this will be A complement or B complement, and this is AND operation. This will become C complement or D complement, and this is OR will become an AND operation. Here AND will become an OR operation, and this will be B complement or D double complement. D double complement is D. So therefore, this is the POS form. POS form of this function realized by taking the F complement and then complementing it again. All right. So this is the way we do the POS simplification. All right. Again, I summarize. So for the SOP form, we write the corner map and simplify for the ones. We do the grouping for the ones. That means for the function values when the output is 1. Those combinations we take and do the grouping. Next, to find the POS form, we take the zero combinations, I mean the zeros, the min terms for which the outputs are zeros. Those things we group by applying the grouping technique of this map, the corner map, the rules as per the corner map, and then we find that as F complement, and then we take a complement of that to get the POS form of the given expression. All right. So how we obtain SOP form and POS form, I hope it is clear. Let us take the realization. So this is the SOP form realization, and this is the POS realization, product of sums. This is sum of products. So we can see the difference. Here AND gates and 3 input. Here AND gates are used and an OR gate is used. Here OR gate and AND gates are used. All right. So in a similar way, let us do another problem. This is a 3 variable function, and let us see the function 1, 3, 4 and 6. So let us write the truth table. More often we have looked in directly into the corner map. Now let us write using the truth table. As I said, truth table, corner map is a pictorial representation of the truth table. So here for 1, M1 is 0, 0, 1, M1, M3, M4 and M6. So these are the outputs, or these are the combinations for which F is 1. Next, we write the 3 variable corner map for this by taking YZ this side and X this side. This is the standard form. You can write the other way also, X here and YZ this side. And then, so we identify the ones and we start the grouping. So there is no 4 possible, 4 combinations not possible. Only 2 grouping is possible. Grouping of 2 ones. 2 ones here and these 2 ones are grouped. So therefore, from grouping, the result is X complement Z or XZ complement. So we want to find, so this is the direct SOP form. We want to find the POS form. So POS form is again obtained by grouping the zeros. So these 2 are grouped and these 2 are grouped. So when you group these 2, this is X complement okay. So when we group these 2 zeros, so we get X. So what is changing here? Y is changing, Z is same. So therefore X complement Z complement by grouping these 2 zeros. So when you group these 2 zeros, what you get is, what is changing? Y is changing, Z remains as 1 and X remains as 1. So this is XZ. So therefore for these 2, you get XZ term, the implicant, and for these 2 zeros, you get XZ, X complement, Z complement. All right, fine. Next, we are going to find the complement of this. So F complement will be equal to, so we have to take a complement of this whole function here. So which results in X complement or Z complement ANDed with X or Z. So this is the POS form of this function, whose SOP form is given here for the full function. And it's straight, and this is the truth table for this problem. Okay, so we can write the POS form as 0, 2, 5 and 7. So M0, M2, M5 and M7. So we have written it here. So for that, this will be the function. Okay, so let us now look into don't care conditions. So how we can use the don't care conditions and how we can simplify the Boolean functions. Okay, suppose if this is the output function for which output is 1. So it's a 4 variable function, wx, yz, and output is 1 for M1, M3, M7 and M11 and M15. Next, the don't care is the SOP form for 0, 2, and 5. Now let us first write only the direct expression for the output without the don't care condition. Of course, we show the don't care by putting an X. So what is this don't care? Don't care is if you want to group them, you can take whatever value you wanted. So that means if you want to add it and make it as a 4, now this only these ones are here, and this don't care means I can club them and make it as a 4 4 square combination. So these two can be taken. Okay, and this is not taken because there are no 4 combination here. So again, this 4 can be taken, but since these two are already clubbed, so left are these 3. So these 3 can be clubbed here with this 1. So therefore, we are going to take these 4. So therefore, we have got the grouping, and the result of grouping all these 4 is W complement X complement, because Y and Z changes here. When you take these X and W and X changes in these 4 rows, and in this column Y and Z remain unchanged. So therefore, the result of this combination will be YZ. Okay, so therefore, now let us see that is all. So therefore, all the ones are covered. Okay, so the output for F will be, now this function is now reduced to F is equal to YZ or W complement X complement. Now when we take the don't care, so we can club these 4 and these 4. So we have previously we have taken M0 and M2 for a clubbing of this. Now we are taking only this. So these 4 can be clubbed, and again these 4 can be clubbed. So when we club these 4, we get W complement Z, and this as it is YZ. So YZ is same whether we, because it is not clubbed with any don't care condition. So here we have taken M5 for the grouping. Here we have taken M0 and M2 for the grouping. So we ended up with 2 different results. All right. So this is F, which is equal to YZ or W complement X complement. And by this combination, the result is F is equal to Y, Z or W complement Z. So we have ended up with 2 equations. Now, for this equation, we have 0, 1, 2, 3, 7, 11, and 15. For the second set, we have 1, 3, 5, 7, 11, and 15. So therefore, the only way to combine zeros is to include the don't care minterms, and therefore we can find the F complement by taking the zeros here in this case. All right, so to find the F complement, we have to take the zeros into consideration. So by taking the F complement, that is the zeros, we get Z complement or Y W Y complement. Next, by taking the complement of this, we end up with Z ended with W complement or Y. So this is by this F complement we have got by grouping all the zeros along with the don't care, and then we have simplified that, and we have taken the complement of this F complement to obtain the PoS form. All right, and this is the result we have got. So therefore, how we can use the don't care condition is explained by this example. is we have explained by taking this example. Okay, so far we have looked into, these are the different topics we have looked into, and we in this session we looked into the POS form and how we simplify and how we can take the don't care conditions also and simplify is what we have seen in this. And in the next session we will look into how to implement the NAND and NOR and how we can use them as a universal gate, and how we can realize so many other functions or Boolean operations by using NAND and NOR is what we are going to look into the next session. With this, we wind up this session. Thank you.